So this video is on the worksheet that I passed out at the end of class for those who wanted extra practice before we take the equation quiz. So on this first problem, which is an absolute value, you want to isolate your absolute value. So I want to get this absolute value of 4x plus 2 by itself. So I am going to minus 7 from both sides. And I'm going to get the absolute value of 4x plus 2 is equal to 3x. At this point, you want to check to see what's on the other side of the equal. Remember, for an absolute value, this cannot be negative. It could be 0. It could be a positive. It just cannot be negative. So I need to check my answers to make sure that they don't make that 3 times x negative. So I'm going to work out two equations. One equation is going to be 4x plus 2 is equal to 3x. The other equation is going to be 4x plus 2 is equal to the opposite of that, which is a negative 3x. So what I am going to do is I am going to get my x's on the same side. So I'm going to get 2 is equal to negative x, and I don't want my x to be negative. It has to be x, so I'm going to divide both sides by a -1, or basically make both sides opposite. Now, when I check that answer, okay, when I check this answer, I need to check this answer here to make sure it doesn't make it negative. And when I do put that in, let me just grab a pen. When I do put that in, 3 times -2 equals -6. So this one is not going to be an answer. So now let's try the other one. So for the other one, I'm going to minus 4x from both sides. I get 2 is equal to a -7x. I divide both sides by a -7, so I get a -2/7x. Now again, I'm going to check that. Okay, if I put this into this up here, that 3x, will it make it negative? And so when I check that, I am going to get a 3 times a -2/7. That's going to give me a -6/7, which means this one's also not an answer. So if neither answer works, your answer is no solution. Now on number 2, this one is a square root. We have to isolate our square root, and when we isolate our square root, we need to check to see what's on the other side. So on the other side, I have this x minus 2. So this is called a principal root when we are taking the square root. And well, when they draw the square root, and our principal root is not negative. Okay, it's non-negative. It could be 0 or it can be a positive. It is not negative. So again, I'm going to have to check my answers. So I'm going to have the square root of 19 minus 6x is equal to x minus 2. I am going to square both sides. When I square a square root, it undoes, and I get 19 minus 6x. And when you have an x minus 2 squared, you have to be careful. You need to either think about the following formula. I'm going to zoom in for a second. The formula I'm thinking about is a minus b squared. That is a perfect square trinomial where we have a minus in between. So I would square my first term, multiply these together, and then double it. So that's going to be a -2ab, and then square my last term. And that's going to be a b squared. Okay. So that's one way to do it. Another way to do it is to think about working it out as an x minus 2, x minus 2. Now, if I'm using the formula, I'm going to take that x, square it. I am going to multiply these together, which is a -2x, and then I'm going to double it, so it's going to be a -4x. I'm going to square that, which is going to be a positive 4. Now, when I am multiplying it out with the area model, you're going to see I'm going to get the same thing. I got x squared minus 4x plus 4. Now I have a quadratic. I want everything on one side, 0 on the other. I always like my x squared to be positive, so I'm going to leave my x squared where it is. So I'm going to add 6x to both sides. And let me just do it in a different color. I'm also going to minus 19 from both sides. And so when I do that, this is going to be 0, x squared plus 2x minus 15. I'm going to factor that. And that would be a diamond that I can use. So what multiplies to a negative 15 and adds to a 2? That's going to be a 5 and a negative 3. So my factors are an x plus 5, x minus 3. This is going to give me a negative 5. This is going to give me a positive 3. Now again, remember, we need to take those and check them up here where my square root is isolated. So if I was to take that and substitute it in, okay, I'm going to check it all the way here. I'm going to get a negative 5 minus 2, which is a negative 7. So that's not going to be an answer. Now, let me write that a little more see-through. So that's not going to be an answer. So then I'm going to check, well, first work out the other one, or actually I did, so I'm going to check that. So now this time I'm going to be taking this and putting it up here. And when I do, I get a 3 minus 2, which is a 1. That is a positive, so x equals 3 is going to be an answer. On number 3, for this, I have to understand how to do exponential equations. I also need to understand that when I have that in both of them, I can rewrite it. I'm going to say let u equal the square root of x plus 5. So let me just write this as a 3u squared is equal to a 27u. Now, I need to get my bases to be the same. I need to get this 3 and this 27 to be the same. I cannot make the 3 bigger because I'd have to cube it, which means I'd have to cube a 27, and that makes that even bigger. Can I rewrite a 27 as a 3 to a power? And a 27 is the same as a 3 to the third. So this right here, I'm going to write as a 3 to the third, raised to the power u. And on the other side, I have 3 to the u squared. So now this is going to be 3u squared is equal to 3 and power to power I multiply. So that's going to be 3 to the 3u. At this point, when the bases are the same, okay, when I did get this base here and this base here to be the same, I'm going to take the exponents and I'm going to set them equal to each other. Okay? So I am going to take my u squared equal 3u. I'm going to get everything on one side, 0 on the other. I'm going to factor out a u. And then when I solve this, I get u equals 0 and u equals 3. But remember, that was not what I'm looking for. I am looking for this x, and I know that the square root of u, okay, so the square root, sorry, u is equal to the square root of x plus 5. So if I have it equal to a 0, I'm going to set this equal to 0 and solve. And I also have it equal to a 3, so I'm going to set it equal to a 3 and solve. Since this is square root, I need to check to make sure that this is not negative. It's not, so I can work it out. For the first one, I'm going to square both sides. So I'm going to square this side and I'm going to square this side. So I'm going to get an x plus 5 equals 0, which leads to x is equal to a negative 5. Okay, on the next one, I'm going to square both sides. And when I do, I end up with an x plus 5 is equal to a 9. I minus 5 and I get a 4. And those are my two answers. On number 4, on one like this, what I'm going to look at is this x to the 1/2 and this x. So if I take x to the 1/2 and I square that, I get x to the 2/2, which is just x to the first or x. So I'm going to let u equal x to the 1/2. And when I square that, I get an x. So here you see that I have an x to the 1/2 and an x. So I can rewrite this as a u squared minus 11u plus 28 equals 0. I'm going to do a diamond. What multiplies to a positive 28 and adds to a negative 11u. And that's a negative 7 and a negative 4. So I'm going to get a u minus 4, u minus 7 equals 0. I'm going to get u is equal to 4, u is equal to 7. Now remember that we had to find our u as an x to the 1/2. So I'm going to put an x to the 1/2 here. So I'm going to have x to the 1/2 is equal to 4, and x to the 1/2 is equal to 7 because of this one, and then because of this one. Okay. Now, again, just a reminder that if I have x to the 1/2, that's really the same as a square root of x. So I need to be careful and make sure that these are not negative. They're not. So now to undo anything raised to a power, I can really raise both sides to the reciprocal of that. Well, the reciprocal of 1/2 is 2. So I'm going to get x is equal to 16. That's going to be one answer. Over here, I'm going to take my x to the 1/2 and raise that again to the reciprocal, which is 2, and I'm going to do the same to the other side. So I'm going to get x is equal to 49, and that's my second answer. So make sure you can do these without help.